Hey everyone, how's it going? My name is Eli, and today we're going to be answering three very important questions that I know you're all dying to know the answers for. Those three questions are, first, how much energy does it take to boil half a liter of water? Second, how efficient is this kettle at boiling that water? Converting this electrical energy coming in, converting it to heat, and using that to boil the water. And third, how much does it actually cost when you're making a cup of tea or a hot chocolate, something like that? With that, let's get right into it because this one is going to be a good one.
For this experiment, what we're going to do is add a meter right at the outlet, which is going to tell us exactly how much electricity we are going to be using. To answer the first question, how much energy does it take to get the water to boil? That'll be really simple because we have this meter.
So here is our kettle. This is where we're drawing our line for our conservation of energy. Any electrical energy coming into the system is then converted, right? It travels down the cord into the base of the kettle, and then it is converted to heat. The heat is transferred into the water, and the water heats up, and that's what causes it to boil.
Pour in my water. So I know the starting temperature of my water was 67 degrees, and that's the same temperature as the kettle. The kettle has not been warmed up at all, so kettle's 67 degrees, the water is 67 degrees. All right, and that will be, the water is boiling now.
Here in the app, you can see that this plug is showing exactly each second how many watts that the plug is using. What's really cool, you see right when it turns on, right there, and then it immediately shoots up to 1472 watts, and then it drops down to about 1450 and stays that way for the next 2 minutes. So with that, I can calculate exactly how much power was coming through. I can also look in the minutes and see that, okay, for those 2 minutes, it was averaging 1430, 1450, 1430 on each of those. And the kettle is rated for 1500 watts, so this lines up really close. We have our first answer, so now we can move on to the next one. How efficient is this kettle? To figure this out, we have to know the theoretical amount of energy required. Thankfully, we have this equation that explains the heat transfer. The change in energy is equal to the mass times the heating capacity times the change in temperature. The mass of half a liter of water is 0.5 kilograms. The heating capacity of water is 4,187 joules per kilogram degree Celsius. And our change in temperature is 100 degrees Celsius, the boiling temperature of water, minus 19.4 degrees Celsius. We cross out our units and we are left with 168.87 kilojoules. We can convert kilojoules to kilowatt hours and get a theoretical amount of 0.047 kilowatt hours. Last, we can compare that with our actual, and we get an efficiency of only 66%. Now, the last question. How much does it cost in electricity to make this hot water? The rate here is 11 cents per kilowatt hour, so multiply that by 0.0704 kilowatt hours, and you get 0.77 cents. So less than 1 cent in electricity to make this water boil.